respectively lie on a plane, and therefore I will have to take an arbitrary point as well. So let me put ABC here, and the arbitrary point P is here, whose position vector can be taken as R. So if this is capital A, the position vector is small a. This is B, whose position vector is small b. And this is capital C, whose position vector is small c. Now, I have to make use of the equation of the plane that we have been using for the previous 2-3 cases, that it is A times x minus x naught plus B times y minus y naught plus C times z minus z naught equal to 0. That is, ABC will stand for the vector that is normal to the required plane, and x naught, y naught, z naught will be point on the plane. So let me now join with AB and AC. I can either take AB and AC, or AB and BC, or AC and BC, any two of them. And therefore, AB is the vector lying on the plane which can be written as B minus A, and AC is a vector lying on the plane which can be written as C minus A. Now, the student has to recollect that AP cross AC will be perpendicular to both AB as well as AC. So consequently to the plane, that is, it will be perpendicular to the required plane. Okay. Therefore, I can find out the cross product of these two, and the components along the IJK directions can be taken as A, B, C. So plug in for the coefficient, and for x naught, y naught, z naught, I can use any one of the points to plug in here, and hence I will be getting that. Let me call the cross product of AB and AC as n vector, and whose components are AI plus BJ plus CK. Hence, we can also get the equation of the plane when you are given 3 points by finding out two vectors on the plane, which can be called as two parallel vectors on the plane. And we can use A times x minus x naught plus B times y minus y naught plus C times z minus z naught equal to 0 to get the equation of the plane.